Welcome to this session where we deal with the hyperbolic identities. Okay. Now, for you to effectively work out the hyperbolic identities, you have to remember the hyperbolic functions. Okay. You have to remember, for instance, hyperbolic sine. So rather sine x is given by exponential x minus exponential negative x over 2. Okay. Again, cosh x is given by exponential x plus exponential negative x, all this over 2. Now, these two are very important because you can use them to derive all the other hyperbolic functions. Okay, so the next one is tan x. Remember, tan x is sine x over cos x. The same applies here. Tan x is given by sine x over cos x. So if you divide sine x by cos x, ultimately you're going to get these. Okay. And these three functions have their reciprocals. So that, remember, we can now derive all these others from sine and cos, sine x and cos x. For instance, tan x, we've gotten tan x by dividing sine x and cos x to give us this particular function here. So 1 over sine x will be, okay, a step back to trigonometry. 1 over sine x, we had that as cosec. 1 over sine x is cosec. So 1 over sine x, similar to how 1 over sine x was cosec x, 1 over sine x is, here it is written as cosec. So this will be the reciprocal of sine x, therefore it will be 2 over exponential x minus exponential negative x. Consequently, 1 over cos x will be sec x. Sec x, written as such, will be 2 over exponential x plus exponential negative x. And 1 over tan x will be cos x. Cos x will be exponential x plus, it is the reciprocal of tan x. So what was in the denominator becomes the numerator, and the numerator becomes the denominator. That's what we mean by reciprocal, or 1 over, yeah, x minus a negative x. Okay, with these you can work out any hyperbolic identities, but remember that for us to come up with all these others, all these, we had to just know these two. With these two you can derive this one, and this one. Okay, wonderful. Let's get to some examples. So here is our example 1. You are asked to prove that 1 plus 2 sine squared x is equals to cos 2x. Remember, sine can also be written as sh, cos can be written as ch. Okay, so prove that 1 plus 2 sine squared x. I want us to work with the right hand side. Okay, so solution. Okay, we know that shine x is given by exponential. Okay, let me just write that. So this will be 1 plus 2 into exponential x minus exponential negative x over 2 squared. Remember, here it is shine squared x, so I've squared it. But for shine, we know that shine is given by exponential x minus exponential negative x over 2. Okay, wonderful. Oh, I've decided to work it out from the left hand side. This one, we could have chosen to work it from this one, simplify it, see if you can get this, but I've chosen to work this, simplify it to see if you can get this here. Okay, so let's expand this further. I want us to square this, so we are going to have, that will give us 1 plus 2 exponential x exponential negative x over 2. Okay, actually over 4, because I've distributed the powers, over 4, and this will be squared. Okay, I hope you see what I've done there. Remember, from laws of indices, if I have a over b squared, that's the same as a squared over b squared. So in our case here, this is 2 squared, I've already squared it, so I have 4. Okay, this is still squared. Okay, let me continue working that. So I will have 1 plus 2 into ex minus e negative x. Okay, ex minus e negative x squared means multiplied by itself, all these over 4. Okay, now I will have, okay, I will have 1, or let me just, okay, 1 plus 2 into, so ex times ex, so let me just take it a step at a time. That will give us ex. Okay, now ex times e negative x, remember it's a negative here, so I will have negative ex times e negative x minus, for this minus here, so I have a minus ex times e negative x, sorry, e negative x times ex will give me ex times e negative x. And then finally I have these times these, but negative and negative, so I will have positive. So here we have a positive. Okay, so this will be e negative x and e negative x. Okay, so e negative x dot e negative x, all these over 4. Notice that these 4, these 2 can cancel with the 4, so I'll have over 2 there. Now I want to remind you something again from laws of indices, multiplication law of indices or addition law, so that from laws of indices, if I have a power m times a power n, that's the same as a power m plus n. Okay, so in our case, when you have, okay, let me just, next step, so you'll have is equals to 1 plus, let me put my bracket there. So when I have x times x, sorry, e to power x times e to power x, as long as the bases are similar, see here, as long as we have similar bases, we can add the powers. So this will be x plus x. So that will give me 2x. So I'll have e 2x. Okay? Minus. Again, bases are similar, using the same principle. So bases are similar, so I add them. Okay? So this will be e will be the base, x plus minus x, or x minus x is 0. So I will have e to power 0. This is the same, e to power 0 plus, now I have similar bases, so minus x will give me minus 2x. So I will have e minus 2x over 2, or I can do away the brackets first, say over 2. Okay. From laws of indices, now by now you should see that you must have had a good foundation in algebra, specifically indices. So from laws of indices, anything raised to power 0 is 1. So e raised to power 0 is giving us 1. So that we are going to have, we will have that as 1 plus e 2x minus 1 minus 1 plus e negative 2x over 2, which is the same as 1 plus e 2x minus 2 plus e 2x over 2. This is negative. Yeah. Okay. So how do I proceed from here? I can find the LCM. Okay. If I find the LCM, my LCM is going to be 2. Okay. So my LCM is 2. So 1 goes into 2, 2 times 1, 2. So I will have 2 plus 2 goes into 1 once. 1 times this, we maintain it. So I will have e 2x minus 2 plus e negative 2x. Next, I open the bracket. Now, if I open my bracket, I will have 2 plus e 2x minus 2 plus e negative 2x over 2. This is the same as I have 2 minus 2, so that will be 0. So that's the same as e 2x plus e negative 2x all over 2. Now, let's go back to our question. This is the simplest we could get. Let's go back to our question. What was our question? Prove that this one we have worked out, the left-hand side is equals to cos 2x. Now, I hope you can see that this is cos 2x, because let's hold it for now. Let's hold this one here for now. We know that cos x is given by exponential x plus exponential negative x over 2. In this case, we are asked to prove that that was equal to cos 2x. See, here it was x, so the value of the exponential was exponential x, exponential power negative x. Okay. Now we are given that our x is 2x. It means this will be exponential 2x plus exponential negative 2x over 2. I hope you can see that this here is similar to this. They are actually similar, hence proven. Okay, so that has taken us a number of steps. It's okay, so hence proven. Let's check another example, example 2. Okay, here is our example 2. We are asked to show that tan squared x plus sec squared x is equals to 1. At least we can work with the left hand side. So we know that tan squared x is sine squared x over cos squared x. Okay, and okay, I see that there's a shorter way and a longer way to go about this. I am going to pick the longer way. Yeah, surprisingly, I'm going to pick the longer way. Okay, so sine over tan, we know now that is given by exponential x. Solution is going to be exponential x minus exponential negative x over exponential x plus exponential negative x squared, because it was tan squared. So this is tan squared x plus sec. We know that sec is the reciprocal of cos. Okay, sec is the reciprocal of cos. So this will be 2 over exponential x plus exponential negative x. It is squared. So this is the side we want to work with to see if we will get 1. Okay, let's get to business now. This will be, again, distribution of powers from laws of indices. We will have exponential over exponential x plus exponential negative x squared plus 4 over exponential x plus exponential negative x squared. Okay, so just a moment, let's do something here so that we save some bit of space. Okay, now I want to find the LCM yet. Yeah, we could even find the LCM at this point. We could find the LCM at this point so that we don't, because both denominators are the same. Or we could first expand everything, but I see it is simpler to find the LCM. Okay, so if you find the LCM, we will have, or maybe let's just expand everything. Let's just go the long route. So this will give me EX. I've changed my mind. Let's find the LCM. It will be, we'll save time. So I have EX plus E negative X squared. That's our LCM. So this here goes here once. 1 times this, we maintain it so that we will have exponential x minus exponential negative x squared plus, again, this here goes here once. 1 times this is 4. So we'll have plus 4. Plus 4. And now we can expand them. If we expand them, we are going to get EX minus E negative X ex minus e negative x plus 4. Was it plus? Yes, it's plus 4. All this divided by ex plus e negative x, ex plus e negative x. Okay. Now I opened the brackets the long way when we're dealing with example 1. We can actually just see that. Let me take you back to example 1 briefly. All these, we already did all these in example 1. So I'm going to skip this step now in the subsequent examples. So let's get back to example 2. There's our example 2. So I know that ex times exponential x times exponential x I will give me e2x, and then exponential x times negative x will give me 1. Okay, I already know from example 1 that it will be minus 1. And then this here times this here will also give me minus 1 from example 1. And plus exponential negative 2x. All that we can find from example 1. Okay, so all these plus 4 over, I know exponential x will give me exponential 2x, exponential x, exponential negative x will give me 1, but now it is positive because all these are positive, so I will have plus 1, and then exponential negative x, exponential x, positive, so positive 1 plus 1 plus exponential negative x will give me exponential negative 2x. Okay, again, simplified further, I will have e2x minus 2 plus e negative 2x plus 4 over e2x plus 2 plus e negative 2x. I hope you can see that here we have negative 2x and here we have 4, so we can do something about that. We will have e2x plus 2 plus e negative 2x, all that over e2x plus 2 plus e negative 2x. So we have come to a point where the numerator and the denominator are the same to give us 1, which one is already here. Okay, so hence proven, hence shown. Okay, I hope that was clear enough. I want us to get to example 3. So let's check another example, example 3. So here is our example 3. Given that a exponential x plus b exponential negative x is equals to 4 cos x minus 5 sin x, determine the values of a and b. So how do you go about this solution? So in this case, we are going to solve the right hand side to see if we can get the values corresponding to a and b. So the right hand side, we will have 4. We know what cos x is. Cos x is exponential x plus exponential negative x over 2. Okay, I hope that's by now that's okay with us. Minus 5 sin x is given by exponential x minus exponential negative x over 2. Okay, we can actually simplify this further. So we will have these two here can cancel with these 4. or we can factor out 2 so that we'll have 4 over 2, which is 2. Okay, so that ultimately we will have 2ex plus e negative x minus 5 over 2 ex minus e negative x. Okay, I hope you see what I've done there. Now I want to open the brackets. If I open my brackets, I will have 2ex plus, plus another plus 2 negative x minus 5 over 2 ex plus, of course you have to remember this is negative and negative, so we have a positive here, okay, plus 5 over 2 e negative x. And we can now collect like terms, so that I will have 2ex minus 5 over 2ex, okay, plus 2e negative x plus 5 over 2e negative x. Okay, yeah, I've opened my bracket nicely. So from your calculator, 2 minus 5 over 2, remember 5 over 2 is the same as 2.5. Okay, yeah, 5 over 2 is 2.5, so 2 minus 2.5 is negative a half e x plus, this will be 2 plus 5 over 2 will be 2, and 5 over 2, which is 9 over 2, okay, plus 9 over 2 e negative x. Now, remember, okay, I've solved the right-hand side, okay? So, in the question, it was a e to power x, okay, let me just write that now. So it means that I will have a e x plus b e negative x being equal to negative a half e x plus 9 over 2 e negative x. If you write it this way, you can obviously see now that a is equals to negative a half and b is equals to 9 over 2. Okay, and that is, those are the values of a and b. Okay, this is a very good question. So I want us to do one almost similar to that as our last example, as example 4. So let's get example 4. So here is our example 4. If 4 exponential x minus 3 exponential negative x is equals to p sine x plus q cos x, determine the values of p and q. Okay, again, we start from the right hand side because we can solve for the values of sine and cos. Okay, so solution, we will have p sine, we know is given by exponential x minus exponential negative x over 2 plus q exponential x plus exponential negative x over 2, which is cos. Okay, so that's the right hand side. Okay, so if you open the brackets, this is the same as p over 2 exponential x minus p over 2 exponential negative x plus q over 2 exponential x plus q over 2 exponential negative x. Okay, then I collect the like terms. If I collect the like terms, I will have P over 2 EX plus Q over 2 EX, okay, should I put minus here? Minus P over 2 E negative X. I've put minus because of this here. But then since this is minus outside, this will be minus. So minus Q over 2 exponential X. It's a minus so that if I were to open this bracket, I will have this as negative P over 2, which is this. Negative and negative will give me positive. Okay? I hope that is clear. Okay. And then I can factor out, here I can factor out e to power x. Yeah. So let me factor that out. So I will have p over 2 plus q over 2 exponential x minus p over 2 plus, sorry, minus again, minus q over 2 exponential negative x. Now I can equate these. I can equate these to what I was given. Remember, we were given that 4ex minus 3e negative x is equals to, so I equate it now to what I've already solved, plus q over 2 ex minus p over 2 minus q over 2 e negative x. If you do it this way, you will notice that this one should be equal to this one here because of this e to power x, e to power x. So that I will have 4 being equal to this here. Okay? So that, let me write that now. 4 is equal to p over 2 plus q over 2. If I want to solve for p and q, I can multiply all through by 2, so that I will have 8 is equals to p plus q. Okay? That can be my equation 1. Okay? For, let me undo that. Okay. Now again, I have a negative, so negative 3, this one here, negative 3 should give me this negative here. Yeah, or I could even open the bracket now. So that negative 3 is equals to minus p over 2 plus q over 2. So that negative 6, I multiply all through by 6, negative 6 will give me, let me start with q, so that I have, okay, will give me negative p plus q. This is second equation. I hope you can notice that I have a set of simultaneous equations. Okay, and with that I can solve for the values of, what was the equation? Values of p and q. I can solve for them using this set of simultaneous equations. Okay, let me just do exactly that. So I have p plus q is equals to 8 minus p plus q is equals to minus 6. If I choose to add them, p plus minus p is 0, q plus q is 2q, 8 plus minus 6 is 2, so that q is 1. Okay, And of course, when I have Q as 1, P will automatically be 7 from equation 1. So P is 7. And there it is. I have my values. And that marks the end of our session for hyperbolic identities. Thank you so much.